the character movement scripts work for our game, Crazy Brainrot 3D. So basically what we have here is we have our constants and our variable. So right now we have speed set here, set to 0 initially. So the acceleration works properly as you start the game. And we have it as a variable, not a constant, because it's going to be changing, obviously. Here we have our constant max speed, which is set to 450. And this is basically making it, we have code, so the speed would never go above this here when we're accelerating. When we first made the script, we had a built-in jump mechanic, but then now we just have that set to 0, so we don't have to worry about that, and we can't jump anymore. Here we have the rotate speed, which is set to 3, and that's a constant as well, and it's detecting how fast the character is going to rotate. And this is tilt, so this is also the same thing, but for tilt, determining how fast the character is going to tilt. This is acceleration, so acceleration in this game is linear, so it's not going to be changing. It's going to be gradually increasing, not multiplying, but by adding it to the speed. We have that constant. We have friction, so as we're not holding in an input, we're going to slow down by this value here. And then you have deceleration, so when you're not holding in, your speed's going to decrease. And it's basically what this is doing, what the difference between friction and deceleration is we have speed. Friction has no effect on speed, so it's determining how fast the character is coming to a stop when we're not holding. So this is directly changing the velocity. And deceleration is changing the speed, which doesn't have an impact when we're not holding an input. So this is what's slowing us down when we don't have an input. Deceleration is slowing down the speed, which is only a thing when we do have an input, and you'll see that later. So we have this physics process here. This is running all the time for our character. So we don't have to do while true loops. This will any if statements will always be running, always be checking, basically. So we have a variable here called rotate direction, input.getAxis, move left P1 and move right P1. What's happening here is it's setting a direction with these two inputs. So move left P1 is the negative input for the A key for player 1, and for player 2 would be the left arrow key. And the positive one would be D key for D key for player 1, and then right arrow key for player 2. And so basically what we have here is you have a function called rotate y, and what's doing is when we're plugging these numbers in, it's going to rotate y by the value inside. So we're doing rotate direction here. So if there is an input on one of these things, if it was move left P1, that would be negative. And then, so that'd be -1 times -1, so negative there. I don't know why we just switched this and then didn't have a negative, that's fine. So basically if we times that by -1, rotate speed, then delta, and that's going to move our character which way we want it based on the direction. Then here we have a variable forward direction, input.getAxis, move forward P1, move backward P1, which is set to inputs W and S for player 1 and up and down for player 2 for arrow keys. And here we have an if statement. So this is what's going to allow our characters to rotate the tilt in the Z direction. So what's going on here is we're checking if there is an input in the move left P1 and move right P1, and the rotation of the character is less than 31 degrees and greater than -31 degrees. Then we're going to rotate the character by the negative rotate direction. Delta is just a constant, which allows it, basically it makes it smoother for the frames. I'm not really sure what it does, but Goda suggested using it. And tilt speed, so that's our constant being used there to tilt the character. So it's basically, what's happening here is as we're inputting D or A, the character is going to tilt until it reaches 31 or -31, or as close as it can be. And then here we have an if statement. This is what's going to affect the speed, so allowing your character to accelerate. So if forward direction, the variable here, so if there's an input in A or D, then we're gonna increase the speed by acceleration each time there is an input. And then what this if statement in the if statement is doing here, so if speed is greater than max speed, then we're setting the speed back to max speed, so it doesn't ever go over the max speed. And why we do this is because if we want to change the acceleration value, it's easier to have this is set like that, so we don't have to only set to things that would make that factor into max speed. So we don't have weird decimals, and it's never going to reach max speed. So that just makes it easier to set to max speed if acceleration would go over it. Then you have an else if statement here. So if speed is greater than 0 and deceleration is less than speed. So what that's checking is it's basically not allowing our character to lose speed below 0, so we don't go into negative speed, which is would be really complicated for character movement, and it really makes like the game janky and stuff. So that's just gonna decrease by, the speed by decel every time that's true. And then to make the speed reach 0, if the deceleration value is if deceleration is ever greater than speed, it's just gonna set to 0, so we don't go under 0. So that's what that's doing. Here we have the next line of code. So what this is doing is it's going to be changing the character FOV. So here, if you have an input A or D and speed is greater or equal to max speed, this is going to make FOV 130. On default, it's set to 113.4. So as you reach max speed, your character is going to have an increased FOV, and that's going to make the character feel like it's going fast. And then else, if it's not at the max speed and there is an input, then we'll just set it to 113.4. And if there isn't an input and it's not at max speed, 113.4. Okay, so here we have what's going to allow our character to rotate. So this is going to allow it to turn and change directions. Oh no, sorry, I'm wrong. This is what is allowing character to reset position after it has been tilted and there is no more input. So we don't want the character staying like tilted and there's no churning going on, or where there's no inputs to keep it like that. So what we're doing is we're checking if there isn't an input on A or D for character 1 and character rotation is not equal to 0. What we're doing here is we're slowly decreasing until it is 0. So if the rotation of the character is greater than 0 and there is no inputs, we're going to decrease it, the rotation of the character on the z-axis, by the tilt speed times delta. And then if if the rotation is less than z, then character model rotation equals 0. So this is making sure that as we decrease it here, it's not going into the other direction. So as soon as that happens, we're setting to 0 instantly. And else, if it's in the other direction, basically, we're doing the same thing, but we're adding the tilt speed delta times delta, and then same thing here. Notice it doesn't go over. We should have set it to 0, so there's no problems there. And then here we have, this is a built-in function that Godot adds. Basically what it's doing is it's calling a function if not is on floor. So if the character is not touching the floor, then it's adding to the y part of the vector of velocity. It's doing a get gravity function, which I'm not sure it does, times delta. And that's basically going to allow the character to fall down. That's built in, so we did not code that. And we have ramps in the game, so this is what allows it to fall after going up one of those ramps. Then this is our last bit of code. This is what's actually allowing our character to move. So here we have input direction, which is getting so these aren't used, we don't use these in our code. So really all it's doing is getting this here. So move forward P1 would be W, and move backward P1 would be S. So it's getting that input, and then it's getting the direction here. This is also built in, so we didn't code this. But what it's doing is checking what direction is happening with these. So these are assigned an X and a Y direction, and this is checking what it is. And so if there is a direction, basically if there is an input going on right now in one of those keys, it adds, it sets the velocity in the X direction to direction.x times speed. And our speed is changing by acceleration, so that's what's allowing to accelerate. We're changing the speed, which is seen here. Same in the z direction. Then L, so we didn't change any part of this code, but here is what allows us to actually slow down when we're not holding in an input. So if there is no input currently happening, then we do velocity.x equal move toward, and that's going to basically gradually decrease x, starting at velocity.x, going all the way to 0, decreasing it by friction each time. So that's what the move toward function is doing. It's decreasing the velocity.x all by friction each time by each frame. So that's what I mean by when friction, speed and friction. So friction isn't the same as decel. So decel affects speed. which so if we were to stop moving, the acceleration our character wants to have the speed, it would be slightly decreasing. But friction was actually slowing it down when we're not moving. Then same in the z direction here. And they have the move and slide function. There's a bit cut off. That's also built in. It's not really clear what it does, but it allows the character to basically move around the map smoothly. And that's all for the character movement. Thank you for watching. Goodbye.